All right, so this video is dedicated to my buddy Josh, who a few years ago took a trigonometry class and has applied some of the concepts that he learned into his work, whether it's plumbing or building houses. All right, so this one's about understanding roofing pitch, and let's see how we know we can use our trigonometry and knowledge to understand it, rather than just following a formula or something. All right, here we go. So what I wanted to highlight is four main components or four main ideas behind the roofing pitch that any standard roofer hopefully should become familiar with. I learned some vocabulary here and learn how to link it to math language. All right. So the rafter length, what does that mean? The rafter length is this represented by this variable C on this diagram. So C is representing the length of the rafter. All right. So right here, the main concept we're going to think of is our good old buddy Pythagorean theorem. And I know I should have put a 90-degree angle implied here. There we go. Now we know that the idea is Pythagorean. All right. So the pitch and percent, this one's one that's not very easy to, because you might think the concept is percentages, but it really is not. The main concept here is slope. So if you understand slope, the pitch will be really easy to figure out. If you understand Pythagorean theorem, the rafter will be really easy to figure out. And this is where it gets more trig advanced. But one of the things that I would recommend, even though we are rarely going to use sine and cosine, it wouldn't hurt to go back and brush up your trig ratios if you forgot them. But for this course, the trig that will be used mainly, or for this course, for this particular idea, because we're oftentimes are going to be using the opposite and adjacent side to this angle here, theta, I'm going to call it theta, that is going to imply that we're going to use tangent ratios, all right? And when I say tangent, it does imply the ratio, not the idea of tangent lines. But do think, I don't think it's a bad idea to revisit sine and cosine, because if you knew the rafter length and you wanted to use that instead, you definitely could solve for theta using the rafter length and another side. All right, having said that, the last one is the one that's the standard convention for roofing ratios. This is a ratio. Remember that x, these little semicolon 12 just means another fraction like x over 12. And the one right here, I want to highlight, this is just a ratio. So hopefully you're okay with ratio and solving proportions and stuff like that. All right, so those are the main ideas behind what's going on, the roofing pitch. So let's solve those now down below. So letter A, I redrew a smaller version of it. It's going to be a 9 feet by 1 foot triangle with a hypotenuse, which we need to figure out, and that's the rafter length. So let's do that first. Remember, our good old buddy Pythagorean theorem. I like to do these in my head because they're easier. I visualize the squares, but if you need to show some work, I'm going to do it below anyway. I visualize what's the area of the square right here created by this is 81. What's the area of the square created by this one? It is 1. So 81 plus 1 is 82 when we take the square root to figure out the side length. So radical 82 should be the length of the side, and it's 9.0 something. So check that, verify that with a calculator. I'm going to skip that part right now. But that's the main idea. And if we wanted to show the work, we will say that's C, because remember this was equal to C. C equals radical 82. The way that we got that, it was C squared equals 9 squared plus 1 squared, which to me is kind of boring. But it gives you the same result. So C equals the square root of 81 plus 1, which is 82. That's probably as much work as I'm going to show, but take your time to show more steps if you need to. All right. That's the length of the rafter. We're done. Check. So we're done with the length of the rafter. What's next? We need to figure out the pitch and percent. So all that really means is let's figure out the slope of this line, of the line created by the hypotenuse, which hopefully remember slope is just the rise over the run. Rise over the run, which is 1 over 9. So all that is saying is that I'm going to call that pitch. Can be represented in two ways, actually. This is one of them, as the slope. M represents slope, and that is, remember that it was 1 over 9. 1 over 9. That is the ratio in which we can represent the slope, but it normally represented as a percentage. So all we're going to do is take a calculator and type in 1 divided by 9. You should get a never-ending decimal of 0.111 ... Bunch of repeated ones. And that means that, look, I'll color code this for you. That means that 1/9 is the ratio. We're going to use this for the last part later. So that's why it's important to remember that. That's the ratio representation of the pitch, and this is the percent. And if you want to write in percent, it really is 11.11%, which I didn't write. So maybe we should write that down here. This is the same as 11.11 ... percent, because remember that one digit of one always keeps repeating. So you can think of it as 11.11%. That's not terrible. All right, the next idea in letter C is to find it in degrees now. The pitch was represented as a ratio. Now let's represent it in degrees, okay? So meaning, what is this angle down here created by those two sides, all right? So not the right angle. Oh, and I forgot to point out, these are all right angles. That's implied for when we have rights and wrong. Otherwise, that wouldn't be, all this math wouldn't work before. All right, and remember that for the most part, because I didn't write the value of C here, relative to the side, this is the opposite. And relative to this angle, 1 is the opposite. Relative to this angle, 9 is the adjacent. Adjacent means next to. So look how the angle is next to this 9. So therefore, we can write that the tangent of that angle theta is 1/9. Oh, I'm going to say, just to remind you what it was opposite over adjacent, right? So the opposite is 1, and the adjacent is 9, as I had pointed out already. Opposite over adjacent. Opposite over adjacent is 1/9. Therefore, we know that tangent of theta is just 1/9, which you could have skipped this step, but this is a reminder if you forgot. All right. To continue, lastly, we want to isolate theta. We don't want to isolate tangent theta. We want this by itself. So we want to think to ourselves, what's the opposite of tangent? How do we undo a tangent? Look for that button on your calculator that says tan, but not tan by itself. It says tangent with a inverse symbol, or it looks like a power of -1, but this means tangent inverse. And that means that I'm going to do that on the left side of the equation, but also to the right side of the equation. And the reason for doing that is tangent inverse and tangent, they undo each other, so that we are left with just theta on the left side. Theta is the tangent inverse on the right side now. So theta is by itself, and now tangent inverse of this fraction, or arctan if you're familiar with that term. And then all we do is take this into your calculator, type it in, and we should get like 6 point something degrees, 6.57 or something. I forgot what the value is, but that will give you a decimal approximation, all right? So you check that for yourself. I'm going to skip that part right now. This is the represented form. That's really how we're going to be going about finding that decimal, and it's in degrees. Make sure that your calculator is set to degrees, not radian. This is in degrees. That's very important. Otherwise, you're going to get a different value than what I will be getting if I checked it. But there it is. That's the main idea for we did the rafter length. We talked about the pitch in percentage, as well as the ratio form. And we talked about the pitch in degrees. The one that's usually the most crucial of all of these, the one that's needed the most, is the ratio as x/12. The standard ratio for them is x/12, all right? So we're going to do some ratios. The good thing is that we already have a ratio before. Remember that. We're going to put a lot of attention to this ratio because it's going to come up later, or soon. Not later, just like right now. All right, and the main thing about ratio, when you see this notation x colon 12, all that means is you can write that as a fraction of x/12. All right, and we want to make this equal to our other ratio. All right, our other ratio, what was it before? It was 1/9, but they're going to be the same now. But we want it with a denominator of 12, right? So we want to make the 1/9 into some ratio instead of denominator 9 with denominator 12, and figure out what that x value is. To solve this is called a proportion. To solve those, we cross multiply. And it doesn't matter if you start like this, multiplying these two, or if you start multiplying these two. I like to write the variable first. So I'm going to do 9 times x, or x times 9. That can be represented as 9 times x. And cross multiplying these two, that's just 12. And we want to solve for x. the way I think about it is 9 times something. 9 times something. How do we undo multiplying by that 9? Let's divide both sides by 9, and we get on the left side just an x. On the right side, we get a 12 over 9. And that simplifies to 4 over 3. And that's our value of x. All right. So what that means is that, let me take this here. What that means is that this turns into 4 over 3. Well, let me write it like this. 4/3 to 12. That's our pitch right here in terms of 12. All right. But that's just the same as 1 over 9. Now we put it with a denominator of 12, however. All right. So this is the way that if you were calling your roofing contractor or provider, whoever supplies you your materials, and they ask you what kind of pitch in terms of 12, you would say it's 4/3. All right. And what that means, I'm going to show you a little picture. All right. Our ratio that we made was 1 over 9. But that person that you're talking to on the phone and it's asking about your pitch in terms of 12, they don't care that you have a 1/9. They care about this triangle. They don't care about with base 9. They're asking themselves, but what about when it was 12? That's their standard unit. Then you know that instead of the 1 being a 1, that's going to be a 4/3. These two triangles are similar. All right. So this is like a smaller version of this one. So in other words, they're asking you to turn your small triangle into a triangle with base 12. And that's what we've done by solving this proportion. That's the main idea behind it. If you need to practice proportions, or if you need to practice trigonometry to understand it more, then come back and watch the video later and it'll make a lot more sense. All right. But that's the main idea in a picture right here, if you ever wondering what's going on there. All right. And then I was shown these cooler pictures, right, or found them somewhere. And let's talk about what that means. Like I said, the standard ratio for roof pitches is going to be with a denominator of 12. And notice how as the 12 doesn't change as the denominator, but as the numerator gets larger, then it makes like a steeper or a higher triangle. All right, that means that it's getting higher. That's all pitch means. And here's some more pictures of various types of notice again how they're all in denominator of 12, but the numerator is either a 7, a 6, a 8, and by that changing, the degrees changes. So what's going on there? If you're confused, let's draw a little bit of what's going on here, because we've seen this before actually, and it was the right triangle from earlier. Look at that triangle. Haven't we seen a right triangle like that before? It was like what we did up here. There we go. So what that means is that remember that this is a tangent ratio. This means that tangent, and I'm writing in red so you can color code how it matches to the color of the triangle. So it means that tangent is, sorry, I should have put a little theta there, or a little degree. That means that tangent of theta is 6 over 12. And we can reduce that to tangent theta equals 1/2. And I won't do all of them. I'll probably do 2 or 3 so you can kind of see what's going on. But remember, like up here above, if we wanted to solve for theta, we want the inverse of the tangent. One tangent inverse, so that theta equals tangent inverse of 1/2. Go ahead and type it into your calculator. I'm going to wait for you. Type this into your calculator. Again, ensure that it's in degree mode. And guess what you're going to get? You're going to get this value. And that means that that's the length of that angle, or the measurement of that angle in degrees. Let's do another one, like 11 over 12. And that would probably be it. So you can go ahead and try the rest of them yourself. And again, always visualize, all right, 11 over 12 means there's a triangle like this. And it's right. And that means that because it's tangent to this angle, that means that tangent theta is opposite over hypotenuse. So that means that this must be the 11 and this must be the 12. All right. So 11 over 12. And how do we undo the tangent? We're going to take the tangent inverse. So that on the left side, we're left with just, and some people, I don't like to do this, but if you're having trouble, just think of it like this. They undo each other. So we're just left with tangent. And on the right side, it is tangent inverse of 11 over 2, or 12, I'm sorry. Type that into your calculator, and what do you think we're going to get? theta equals 42.51 ... This right here, right? Makes a lot of sense. And that what that means is that the angle, the measurement of this angle is 42 point something degrees. Take some time if you want to and try these yourself. You should get the answers right there. Look, they even give you the answer for you to check your work. And a cool picture that I found, shout out to pveducation.com. Go check them out for this cool picture I found. Yeah, they give you every possible triangle that you can see. And I won't do all of them. I'll probably do two and let you try the rest. But it shows you how they calculate these degrees. Just think of a right triangle. Let's pick one like 5 and 12, 5 to 12, because that one doesn't reduce. And I'll use blue color right here. So let's focus on this guy right here. You know what I'm saying? So that means that it has a height of, what do you think? Oh, the bad part is that this is already labeled for you. So, okay, that's the 12, then this must be the 5. And the good thing is we don't need to find the length of that hypotenuse for this idea. I messed up right there, big time. But, oh, that's bad. I had done a decent job at first. It's all right. I think you follow what I'm trying to do here. Okay, good. And that triangle highlighted in blue, that's a right triangle, is what I want you to focus on. And then we want to know, in other words, what is this angle right here? And they tell us that it is 22.62. So let's show it. Let's show it here on the side. We know that tangent, I'm going to call it theta. Tangent theta is, or blue theta, because I've been using theta a lot. Tangent of blue theta is a 5/12, opposite over hypotenuse. And then I'm just going to skip the work. Whoops. I was showing it even though I said I was going to skip it. We know that theta equals the tangent inverse of 5/12. Enter that in your calculator, and of course you should get a 22.62 ... or whatever right here. So that's how they're getting that. All they're doing is, what's the opposite? What's the hypotenuse? Entering this function in the calculator, and let's do one more just to be sure that we know what we're doing. Let's do it in red. I like that red color from before. Oh no, but we already have a lot of red here. Let's use something like green then. All right, let's do 9/12. I don't know if we've done that one before. No, 10/12, this one right here. Boom, there we go. So what is, since we already know the base is 12, then this height in green must be 10. That means that this whole thing is 10. Ignore the 5 now from before. That means this whole thing is 10. Good thing is we don't need to know the hypotenuse. We don't really need to know that. And we already knew this was 12. But that's all right. Let's just figure out the tangent ratio. What's the tangent ratio? You try and write it yourself. Tangent theta is 10/12. Can we reduce that one? Absolutely. That's a 5/6. And then, oh man, I showed all the work. It's all right. Theta equals tan inverse of 5/6. Maybe you got there before I did, so that's cool. And what do you think that answer is going to be when we plug it in the calculator? Let's double check. It better be this, 39.81 ... I'll give you some time for you to finish, and this in degrees, don't forget. Give you some time, if you want to check any more or all of them, there, take your time and do it. But that's the main idea behind the roof pitch and right triangles.